On the point challenges, both seemed to be interesting, and so I had to try it out. Basically, we are given these files that you can see, that is both that the binary, and then the source file, that is a .c file, and then you have a docker file for deploying the docker instance, a flag.txt, and the linker and libc for the binary. So basically we can check the file type of both, and we can see that it's not stripped. So basically we have all the debug information and the names of functions that we need. That's awesome. The next thing I would try to do is just check the linker and its libc, and you can see it's set accordingly. We can try to run it, and we can see that, hi, how can I help? And maybe we can say with a knife, I guess. Okay, and it says, sorry, I didn't understand your question. So basically you can like launch this with radare and check it. So for simple analysis, for listing the functions, then we can seek to main, and then we can check the disassembly. So basically what this is doing, basically it is printing out how can I help you, and then your input is compared with give me the flag. So it does the string compare thing, and if that is equal, it will just say lol no. So I think this is laughing something. Then the next question will be asked is, please give me the flag, and then actually please give me the flag, and okay, let's see, I'm not really sure. So help, I have no idea to solve this, and okay, may I have the flag, and okay, this is really confusing. So we can check the source code since we have it, and you can see that it's saying give me the flag, and if that is compared to our input and it equates to true, we get a lol no. Then this is just a no. So basically I think the interesting part of code is this one. So this snippet is interesting. So basically if this is true, it will say I'll consider it, then sleep for 15 seconds, and then check if give flag, that is this variable, if it's true, that is 1 or something positive, it will go and cut the flag.txt, else it will say no. So basically we can also notice that it's using gets, which is a dangerous function, and then you can see it's using string compare. So basically this function of course compares the string until where it finds the null bytes, while gets reads input until it finds a new line. So basically there's that commotion there. So we can use that to our advantage, I guess. So I'll just call out my pawn script and then give it the name of the what, the name of the binary. So we can vim it, so open it, and now we can try to do something like p.receive, I guess. So this one, we want to log this one out to the screen, so we can use something like .decode, and then we can use log.info. Then we can continue and give it some input. So basically we have seen that there's this string that is really awesome. So basically let's see. So we need to equate this, and this needs to be true, so let's call it answer here. And let's start our payload. So basically our payload will be equals to the answer, then you add some null bytes. So basically this will end the string for the string compare. Then we can continue giving it some pattern. So basically this pattern, we'll get it from cyclic, and we want something like 100 bytes. So let's see. So this will plus pattern, I guess, something like that. So let's see. Another thing to notice that let's check the source code. This give flag variable is initialized in the first it's initialized way before we can even get our input. So basically in the stack I checked and I saw that there is no way we can overwrite the give flag from our input. I think this was something to do with, let's see, let's see. Yeah, so yeah, we are here. So on the source code you can check and see that our flag the give flag variable is initialized to 0 here and it's rbp minus x444, and then our variable is rbp minus x40. So basically what this means is that this won't overwrite this no matter what, it won't overwrite that. This is way above our variable, and we can try to check that. So I'll just do a run and let's see. So it says I'll consider it. Let's just break it using Control C and we can check the stack, I guess. So examine, basically I think let's just use a script for this. So yeah, let's use this one. So the next thing we want to try to do is maybe give it a continue, then we can break there, then we can disassemble the main function. From here we can break here, that is in the return value of main, and we can continue. The sleep instruction is really annoying me. Let's see. So it says, sorry, I didn't understand the question. Interesting. Continue, and can we hit enter here? Sorry, I didn't understand the question. That is really interesting. Let's see what you're sending in wrong. So we have that one. Okay, so we need something like, we need to send the input. So this will be like something like p.sendLine and then the payload. Yeah, exactly. How can I help you? And then you're switching to interactive mode. So set disassembly to main, to Intel, and then set the pagination to off. It says I'll consider it, so let's just break here and disassemble the main, I guess. And let's check our variable. So basically this, the value that holds 0, that is the give me variable. So we can examine it like that. And that's weird because it really has a large value. Can we print it? Yeah, holds a really large value. So that was the value. Can we get this one? So examine the string here. So this is supposed to have a string, that is our value, and we also can't access it. So let's continue. We see we hit a segmentation fault, and this is the return value. So we can examine what is in the RSP, and I just forgot, we need something like gx, I guess. So this is the value. So let's see. Okay, I just closed that and now we can't access it. So let's see. So disassemble the main, I guess, and let's set a breakpoint after our gets function. So this is annoying. Yeah, so after our gets function, so where is it? here. So let's set a breakpoint at main plus 70. Yeah, and now we can check our variables, or we can also check the stack, I guess, like 10 values from there, and you have nothing. Interesting, really interesting. Get so okay, so let's examine the string here, and you can see we have please give me the flag. So that was entered correctly, but was our pattern entered really? Like maybe we need 10. Yeah, exactly, and the pattern was entered just right next to it. So let's see what is RBP. So examine, we saw that the other variable was RBP minus 44, so that was x44, and we can see that, let's see, we can see that it's still 0, and then you can check the address and we see that it's above this one. So this was DAFC, so this is above the B00. So basically you can never overwrite this value. So the next thing we can try to do is try to overwrite the return address and then jump back to our function and try to go to the function where it's reading the flag. So that's what I'll try to do in the next 1 minute. So we are just going to get the offset and then everything will be smooth. Why am I saying that? It's because there is no PIE, so basically we will always be knowing the address of code before it runs. So we have a segmentation fault, disassemble the main function, and then we can examine what is in the RSP. And I think we need to just print it out, I guess, as a string. Not really. I think GX will help. So yeah, something like this, and then you can try now something like cyclic tackle, and then this requires a 4 byte, so I'm just going to get rid of these ones, and we see that it's 38, so that is a little bias. So I'll try the other one because this is more accurate. So yeah, so I guess I'll just get rid of these ones, and we get that this is 34. So to confirm that, I'll just use BBB. I'll just give an input that is more clear, like a pattern of like letter B's. So basically what I'll do, I'll just get rid of and get 34, I guess. Then we add something like a couple of B's, and basically we take into account the canonical addressing. Yeah, then we can hit continue. Yeah, and we see that we have taken control of the instruction pointer, so our offset was in 34, so that's nice. The next thing we can try to do is get an address on where to jump to. So just take that to Intel and then pipe that to less. Then you can go to the main function, and then from here we just need to jump somewhere we can read the flag. So let's see, so this is where it's calling a system. I guess I'll jump right into here. So we will output this one, then go directly to system. So yeah, guess this one. So let's see, we can use P64, so that will just pack the address into 64-bit, and then yeah, I guess we can also disable the GDB for this one because we're pretty sure we are in the right track, and it says I'll consider it. So we wait for the 15 seconds of sleeping, which is really annoying actually. Yeah, and we get the flag. So this is fake flag for testing. So you can change the values to remote, to the remote address and port, and from there you'll be able to solve the challenge. So see you next time.